So here's a video for you to help you get through the gas laws. Now, on this screen, you will notice quite a few variations of the gas laws. If all you have is volume and temperature, well, you can use that equation. If all you have is volume and pressure, use that equation. Pressure and temperature, that equation. If you have all three, we use this one, which is called the combined gas law. Now you're going to start to see the term standard temperature and pressure. Standard temperature and pressure. What does that mean? Standard temperature is 0 degrees Celsius or 273 K and 1 atmosphere or 760 torr. There's lots of different ways to measure pressure. Those are two of them. When you are at standard temperature and pressure, you can use this lovely conversion tool, moles to liters, which we've used in the past. And don't forget, if you have to go to Kelvin, just take your Celsius and add 273. So let's take a look at a problem. So the first thing I would recommend when you do a problem is you figure out what you have, because sometimes they're going to give you more information than you need. Not the case in this problem, but let's take a look. A helium balloon with an internal pressure of, all right, so I have pressure, and a volume of that, so I have volume, at that temperature. Interesting. What volume will the balloon occupy at an altitude where the pressure is and the temperature is, negative 32? And notice it said what volume? Well, sure as heck looks to me like we've got all three variables. So we're probably going to want to use this equation right here. All right. And by the way, I know in middle school they teach you to write all these things out off to the side, like P1 equals and T1 equals. I think that's a great idea. I don't have a lot of space, so I'm not going to do that. But the equation above is P1 times V1. So P1 is 0.997 and V1 is 3.07 and temperature 1 is 17.5. I can't use that till I add 273 and make it into Kelvin. When you add 273, you get 290.5. I already did the work ahead of time. So what do we have on the other side? P2, well, that's going to be 0.653. What volume? Well, I don't know V2. And the temperature, again, negative 32 plus 273. So you're subtracting 32 and you're going to get 241. Okay? Now this really overwhelms students, and you could do this one of two ways. Some students will simplify here and they'll simplify here. You can do that. Me, I like to do it all at one time on the calculator. So cross multiply. And when you cross multiply, you get 0.997 times 3.07 times 241 equals 0.653 times 290.5 times V2. And how do you get V2 alone? Well, you're currently multiplying, so divide by all that junk. I know, it's a lot of writing, but like I said, I just like to do things one time on the calculator. I don't like to do them more than once. The other problem with doing the math along the way, so if you would have simplified here and simplified here, you should have gone to only 3 sig figs on both sides. And the problem is that as you round along the way, your answer at the end becomes kind of off a little bit. Now, there's ways kind of around that. Carry an extra digit along the way and then go to 3 sig figs at the end, or you can do it like I did. So what did I do on the calculator? I did 0.997 times 3.07 times 241, press equals, divided by parentheses that times that parentheses press equals. And you get volume 2 as 3.89 liters. And I think it's important that you go back and kind of think about what's happening. So if this was our pressure and we lowered the pressure, typically the volume goes up. Think about a sponge. If you squeeze on the sponge, pressure goes up, volume goes down. And our temperature went down a little bit. So that does have a factor in it, but just kind of look and ask yourself, does my answer kind of make sense? That does seem like it's in line with the answer. All right, let's look at another sample. There are 1.2 liters of gas. Liters is volume. You got to know that, you guys. At a pressure of, so we have pressure. The gas is compressed until the volume is that. What is the new pressure? Well, hey, I only have volume and pressure. If you come back up here, that's this equation. So let's do P1 V1 equals P2 V2. So P1 is 0.98, V1 is 1.2 equals pressure times 0.32. Divide both sides, grab your handy dandy calculator, and you get P2 equals 2.15 atmospheres. Pretty nice. One more problem on this. The pressure in an automobile tire is 2.07 atmospheres. All right, pressure, so we have pressure, at 27 degrees Celsius, well, temperature. What will the pressure be if the temperature is increased? Well, all I have is pressure and temperature. And if you go back to the top, pressure and temperature, use that equation. Plug in what you know, solve for what you don't. So P1 divided by T1, again, you got to go to Kelvin. And when you add 273, you get 300. I don't know P2. And again, add 273 and you get 312.10. Cross multiply, 2.07, 312.10. I don't know if there's a zero on there. I made that up. 300 P2. Divide by 300. And you get 2.15 atmospheres. And that should make sense. At this pressure and that temperature, well, the temperature goes up, pressure should go up. And did the pressure go up? Yes, it did. Now, the next time we come back, we're going to take a look at the ideal gas law. But for now, that will get you through one worksheet. So remember your problem-solving strategies. Highlight or write down what you were given. Think about all the variables you have and what you're looking for. Pick the best equation you can. Plug in what you know, solve for what you don't. Don't forget, you have to be in Kelvin.